Hey everybody. As I mentioned in my announcement, we're going to be doing some easings today. So on a previous stream, I had added some easings to Tiramisu, and I was writing the tests for those. Um, I went ahead and submitted that PR recently, and the author Renata um, suggested that this was becoming too much, and I kind of agree. Um, what they meant by that is that these functions are like really well known, and they're not specific to tiramisu. And so they and Haley suggested that we make a separate library. So I'm going to create that today, and then because they're the ones in Tiramisu. There's the easings.net, which is in JavaScript that we've referred to a lot. There's several implementations in Elixir as well, as and some others. So like this is a thing that I was tempted to go, let's use a JavaScript reference implementation from easings.net and use that as a test, or like a test double is not the right word, but like a way to compare our results of our functions to a known implementation. Um, but the thing is that unbeknownst to me, Haley, the creator of Luster, had created easings for Luster UI, and those are available, and they do basically the same thing. So the goal here would be make a very simple library. We're going to do just functions. I'm not going to make. I think the sort of like give it a named function rather than pass it a regular function is fine for a higher level library. But if we're just trying to, like, there's extra overhead in that. And then if somebody wanted to do a custom easing, that's something that you would like add on top and say, well, these known easings are basically we can name them, but there's no reason you couldn't pass your own function. Um, so the goal here will be um, we will. I just made this new GitHub project, as you see on screen. We will, copy the implementations, make a simple Gleam project here, and we will make this so that we can put this as a dependency of Tiramisu, potentially of anything else that wants to use it. And then I would hope that this can be pulled into the Gleam community organization, but I don't know yet. We'll see. That's a thing that's kind of that's a thing that we don't really know whether will happen yet. So I called it just easings. There's really not any reason it couldn't be called something else. But I want to get this done fairly quickly, so we can get back to messing with our game and testing out the transitions that we've already created there and like tweaking them and whatnot, whatever we need to do. Okay, so here's the PR where I added the easings to Tiramisu, and you can see like these things are very kind of tedious. What I wanted to point out is when Haley called out, "Hey, I did this for Luster UI too." There's an existing implementation here, and I think they have tests. So what we can do is maybe take this. There's a bit of a different like feel here. I kind of want to focus on pure function of t to modified t. And maybe we don't do it like this, but perhaps let's see if there's a test in here. Yep, there's a tween test. So what is this plot? I think what they were doing here was a snapshot test. Okay, so this birdie must be the snapshot. Import birdie. Plots a function and takes a snapshot using birdie. Okay. Right, so, okay, that's fine. Trying to parse this in my head. Okay, so they're making a set. Yeah, so folding over range 0 to the number of steps. And then add, okay. And then making a snapshot. Let's look at that birdie library real quick. We can possibly snapshot testing. We can make use of this. So okay, so then we can do something like this. Let's look at what this is. Okay. Okay, so the content has to be a string, so we could probably do, if we do like a list of tuples, perhaps, we can do string inspect on that and use that as the snapshot. That would be good. Okay, so like I said, I've got this. Let's copy that and we will make a new project. So okay. And we're gonna do, can I do it in the same directory? Yeah. Let's call it Gleam Easings for now. We may rename it later. And we will do that. So, name. Let's support that. Let's just call it Easings. The thing is, I do want to publish this to Hex, so I mean, I could do Gleam Community Easings. I just don't know if they're going to accept that. Okay. Gleasings? That sounds bad. Ease and Gleam. Okay, well, let's just do this. Okay. Okay. So we've got the stuff here. I shouldn't have populated it with the git ignore. Let's make sure the Gleam Tommel is fine. Okay, so we're gonna add for development Birdie. Okay. Okay, let's run Gleam test, make sure we can compile everything. Okay. Now, let me look at the README, make sure. We'll fix this up later. Let's just add everything and make a generate project commit. Okay, so I want to I'm really not happy with the name of this project, but there's nothing requiring, since we don't need a main, honestly. I am going to rename this to Easings. Now we could, like in the future, if this gets accepted to the Gleam community organization, then this will be Gleam community Easings, and we'll just update that, and that's fine. But I don't want to assume, right? So what we're going to do now is I think we'll just copy and modify all this business, because I don't want to rewrite it. But I do want to get it over there without having to do a lot of retyping. So we're not gonna do everything the same way, but we're just gonna have to reuse this. Okay, so we're gonna need import float, Gleam float. We're gonna need Gleam community maths, so let me add that. Gleam community maths. Okay. And I don't think that there's anything else in here that, yeah, we've just got float and okay. So now we're gonna do red. I'm not going to expose that. We're just gonna say linear to use a float. And we might do something like pub type easing is a function. How's that defined over here? There was this. I just want to look at what the syntax is for the function type. Not that. Like we could, reuse some of this code too, but again, I want to keep this as simple as possible. I actually did want to go into the test, because I think that that's the bit where I saw this. Okay, it's just fn. I don't know why I couldn't. So this is fn of float to float, right? So that will allow us to make it's nice to expose this type, so that if we like build something on top of it in Tiramisu, we can make use of this, right? Um, okay. Um, we might refer to the easings.net links here. I think that's probably a good way to do things. There's a question about whether I do ease linear, or whether we'll expect people to do easings.linear and then you get easing in the name. There's sort of a pattern here and also in the Luster UI. Go back to this. Of, well, they don't use, they just say quadratic in. Yeah. So I think I want to keep it. Let's say functions for fluid or for okay. I don't see a reason to clamp like they do in Tiramisu. I think that's useful from a framework perspective, but it's not useful from a pure function perspective. That's something that I don't know if there would be use cases for going beyond 0 to 1, but there could be. So, all right. So let's say we could name them similar to Luster, quadratic in, quadratic out. I think that's a good way to go. And let's get this going, and I'll put it up in here, and we'll just kind of plow through the. I kind of want to get it in line, and so I can do like this, and then we'll go back and add the documentation at the very end. There's probably a way I could script my editor to do this automatically for me, but it's okay. Yeah, and I want these to be as pure as possible, because I think that if we go and start going like adding, this is just a transformation of the time during the animation. Hello, Brave. Welcome to the stream. So we don't care about like well, what is the scale of the things that that we're animating here, right? Um, we what's going on there? We only care. Why is this not working? Oh, I accidentally got rid of the T adjust. Sorry. Oh, then I need to. There we go. So I don't care about like what is the scale of the thing you're animating. I only care about how are we modifying the progress through the animation, right? That's what easings are about. So I'm not going to, like in Tiramisu, they're like, hey, here's the T, and then we're passing some things in, and these are like, some of them are constants, I think. But there's also like a, what is our start thing, and what is our, like, so what is the value at 0, what is the value at 1, and I'm going to scale that for you, and I just don't care. Like we're not that. I don't like this pattern. I want these to be as pure as possible. So I mean, this is okay. Let me just stick with that. This is still a pure function, right? All of this is still a pure function, but what I want to do is focus on the easings only, not on how are you going to use this easing, because this assumes that your values are floats, but Tiramisu has easings across vectors, which is a very reasonable thing to be doing. So I only care about the time scale transformation. Okay. All right. Let's see. Cubic in. Sorry for the bloviating there. All right. And we'll do, hitting too many returns there. Cubic out. Float. Okay, and then when we get this done, we will have we'll have a nice focused library. We'll add some snapshot tests to it, and we will adjust our PR. So I hope to get it to the point where we can do that today. I may have mentioned in a previous stream when we did easings in Fable, which is a company I worked for nearly 3 years. Really enjoyed doing that. Thank you for the smiles and things. I really enjoyed doing that project. And one of the things that we did in that editor was to rather than implement them very simply like this, we had an easing editor. So like you could adjust the curves of the easing. And so we implemented it as like an array of Bezier curves. So like we could have 6 points. So you'd have the start point, the end point, and the control points. And that was like 6 floats. And each one would indicate a curve. So we kind of faked this bit, like, you know, and there were floating point errors and such. So I don't know why I'm bringing that up, but just to say that, like, I've done this before. And this is not particularly exciting content, I realize, but we're gonna power through it. See, we're almost halfway through already. And we'll get our tests running, and then we'll move on with our lives. But the neat thing about having that editor was that if one of those stock easing functions was not quite right, you could poke at it until you were happy with it. And that's something that creative people, they're always looking for. How can I make this do the thing that I want, rather than the canned thing that somebody thought was a good idea. That was really important for our editor, but it in this case, we're not so concerned with providing a generic way to do this. There is a potential that I could go back, and that might be a fun project at some point, and port that to Gleam. Is this not half of pi? I wonder if I should use maths.py there. Something to think about. It may not be important, and like, do I want to call maths.py every time and just have it return as a constant? I don't know. Okay. Sign out. But what we could do is say, like, there are constraints on that sort of there are constraints on that sort of problem, in that you can potentially create a set of Bezier curves that are pathological, and don't go from 0 to 1. they don't start on 0 and they don't end on 1, and so there might have to be like a validation thing. But that might be an interesting thing to implement. One of the things that was really challenging about it is that there's multiple ways to compute the value of a Bezier curve at any point, and I won't say some of them they're not pathological, but they're more expensive than they should be. And so what this technique that we used did, and you can see it in, there's a JavaScript package. It's not the Easings.net implementation, but there's a JavaScript package that takes that same sort of format, and you have like the in control point and the out control point and the start and the end, and it's 1D Beziers, right? You're not doing 2D or 3D Beziers, but it would use something akin to Euler approximation. So if you ever done calculus and you had done a numeric method to compute the tangent, right? It's akin to that, but the one of the traditional ways for computing a Bezier curve is to take the control points and like do this one arithmetic transformation, and you like reduce it to one less point on the curve, right? Hello, welcome to the stream. And so it was using something. It wasn't using that. It was like, we're going to pre-approximate and do a fixed number of steps. And so it had limitations, but most of the time you wouldn't notice them. So we ended up using, well, I say we used that in JavaScript. We started off in JavaScript. We rewrote the engine in Rust, which was kind of necessary to rethink some assumptions about the initial engine for the animation tool. But there were challenges there porting that, specifically because we needed to run in the browser. It was so that meant we were running on WASM32 target, which meant we had 30. I think technically you could use 64-bit floats, but there was no guarantee that the platform would support them, even if the target supported them, the compiler target. So anyway, I feel like I'm rambling, but I'm like trying to make this more interesting when this is what I'm doing here is really mechanical. um, so we've got so we had some challenges of like something just wasn't exactly right um, when we ported it, and there it ended up being that like I think the math there was okay, but that was the very first thing I did when we started porting the engine to Rust. When I say port it wasn't a port. It was like we ported the concepts, and we made sure there was enough compatibility. But in the end, it was basically a rewrite. Okay. Back in is not the best name, but it's fine. Okay, so we're gonna have to take it with some of these. Yeah, there's gonna be some constants, and that's fine. We'll leave it broken for now. I'll fix it in a minute. Back out. Some of them may not be able to be constants, unfortunately. Okay. This is one of the transitions that I actually wanted for our game. And here we are, like, having to implement it ourselves. Because, so let's look real quick. So this is the game we're being inspired by. What I wanted is like when you get a match for the pieces on the board to like grow slightly and then like shrink out quickly, and that's what the back in would do. So like it would go like if we're tweening the scale of the thing, right? It'll go bigger and then it'll go down to 0, which is kind of what I wanted. Okay, so let's move this up. And we'll see what we can do in terms of making those constants. Some of them involve pi, and so we won't be able to. We'll have to like copy that to every function, or make a function that is private that does it. That could be okay. But you can see here, like this is, you know, the only weird things here that we're doing is we're using the Gleam power function, which returns a result. And so we know that this is going to be safe, but there's a potential there if you like you use an invalid exponent, you can get not a number, and I think that's why it's a returning result, because we don't want to get not a number at any point. So we're just doing a panic there. If it doesn't, there's no reason it should, as long as our our t values between 0 and 1, it's safe. But if we did something funky and that ended up being it's either the base or the power, one of them will cause it to panic. Let's see. So if you take a -1 to a fractional power, that's an imaginary number. Sorry to tell you. So the power function doesn't know how to compute that, so it returns an error. Okay. So that's why we're doing that in some places. And it was easier. I think when I originally did this, I was like, oh, let's do result try. No, it's easier to have this assertion because if you're giving it bad inputs, we don't want these functions to all of a sudden produce a result instead of just a plain value, right? Okay, we're reaching the end, I believe. And it would be nice if we could get, wow, that's crazy. We got the bounce. The bounce is the last one. It'd be nice if we could get the pictures from Easings.net into the docs. That would be great. Yes. Well, okay, but the thing is, if base is 0 and exponent is 0, that's still safe. That's 1, right? I think it's more about fractional powers of negative numbers. It's like square root of -1. That's literally the example they give. Yeah. It's not defined? Okay. Well, my memory of that particular math is probably out of date and inaccurate. So it may return a value. That'd be a good thing to test. But I'm not really. Okay, so here we're gonna change this. This is gonna be bounce in is the outside of the bounce out. Okay, and then we'll make that was a shortcut I did. Okay, here's some stuff that's like some crazy constants, but bounce is the weirdest one of them. So I'm not surprised. In fact, if you look at the Easings.net implementation and of bounce, there's some bits with, yeah, we're just gonna, minus equals inline. Like, what are you people doing? Like, there's no reason. Okay, I got too many. Yeah. There's no reason to do that. Like, if you're gonna do minus equals in there, like, do it at the top. But they did it in every clause, and it was really confusing. So I had to like write it in 2 different ways and see which one was correct. It's kind of not great. Okay, so bounce in out is our last one, and then we can write the test real quick. So this shouldn't take too long. And this one we're gonna have to reframe in terms of. I say we write the tests, but we want to do. Okay, and here I know like I use the T for the argument, but all the Easings.net functions use X inside, and so ease of porting, it was named that way. Okay, so let's see where the warnings are, and I think it's just so the C3 is a constant. Okay, so C4 because it calls maths.py, I don't think that we can. I mean, we can pre-compute that, I guess, but I don't think that we can. We can't make that a module constant, right? So these are not going to be public, but I'm going to put them up here, and we'll see if it lets me do that. Here we go. Okay, so let's say const. Yeah, it's not liking that. So we can do what I've been doing when I was. Yeah, see, like here when I was writing the test, I was like, let's do it in some other program and see what it comes out with. This 1.7 0158 looks like square root of 2, but I don't think it is. No. Square root of 3? No, but it's close. I'm not sure what that is. It looks familiar, but that's as far as I go. Okay, so let's just go ahead and recompute these things. Times 1.525. I don't actually know what these constants mean. They're just they're used in the Easings.net, and this will be +1. And I think that what we could do potentially is, let's see here, that C4. Where is that C4 down here? Okay, so this is 2/3 pi, and this is that is a weird way to construct it, but okay. Yeah, let's just pull these out into constants and we'll pre-compute them. And yeah, it's going to complain, hey, I was expecting a constant. So, okay, where'd our calculator go? So we're going to do, can't even read that. Okay, so we're going to do pi times 2 divided by 3. Okay, we'll copy that and we'll just use that. And I'm going to go, I'm going to put a comment here, which is 2/3 pi. That's so weird. This would be like 4/9 pi. No idea why. No idea. Somebody figured it out, right? It's basically what it amounts to. So, and that constant goes in that spot, makes the function look nice. Okay, times 2 divided by 4.5, and we'll copy that. And this is C2 plus 1, and this is, what was it originally? C1 times 1.525. Okay. Okay. I wish you'd put it on that line here. Okay. We'll do it like that. These are not exported, so I'm not concerned about documenting them other than here's what they are used for. Okay. So now that I've got all these, the last bit I want to do in this file is to get links to the appropriate functions on easings.net. I think that that's a good way to document this. So easings.net. So there's no linear. Okay, quadratic, quadratic in. Okay, and then we'll just put that. I wonder if there's a way we can do the, it looks like these are really regular, so I can probably just, let's see this exponential one. Yeah, okay. So I'll say ease in quad. I just want to make a link to it. And then I'm gonna try to speed things up by copy pasting and modifying. Okay. So this won't take too long, and then we'll write our tests and we'll move on with life. It'll be good. Okay. And we can probably publish. So, how's everybody doing today? I'm having a pretty good Sunday. Looking forward to the holiday season. We're going to keep it pretty chill, I hope. I will be here, I think, on the 28th. So we'll do a stream then. And I don't even know if these words cubically, quartically, quadratically. I guess quadratically is a word. Is it quart or quartic? It's quart. I'll need to double check when I do we'll generate the docs. Something I've never done with Gleam. Should be. Oops. In, out, quart. Okay, I'm going to copy this one for modification for quintic. Quintically. Honestly, the better way to say that is eases in using a quintic function, but here we are. It would be nice. The thing is, these are like embeds. They're not like functions that I can just, or images I can just pull. I can't really do that with this. So here we are. I really would love that to be in this docs page, but it won't be. So if we get this done, we will move on. What I want to do for the next stage of the game, it doesn't require this. This is just something that I need to do, and I don't really have as many opportunities to do this on my free time, except for when I'm streaming. So we will. We'll finish this and then I want to try to get the controls such that I can test some of the transitions that we've already laid out, and that's the next step on the game. There's a bit of, I don't know, I have a little bit of trepidation about the game state, and like, I don't know, in some ways the game state is written such that it's done, right? Like, you know, the game state is known, and things can happen with the way that I wrote the logic, where it would potentially make it like annoying to test things. So I'm not sure about how that will play out. But one of the things that like I've never been really that comfortable with game development is like getting a minimal test of some functionality and then like being comfortable throwing it away. because I'm very much a like plan things out and write them as well as you can and then refactor if it needs it type of person. I'm not as good at writing prototypes, right? Um, so that's a thing that how would you describe this circular? It's kind of an arc, right? Easings circ. Not really circular. I think what they're trying to say here is it's because that's more like that's an ellipse. That's not a circle. I'm sorry. We are nearly there. And this is out. We'll need to double check all the doc links here that I'm putting in. Let's see. Let's see what they say here. They don't really talk about what it is, right? But you see, this is the transition that I really wanted. I was like, right? It spends over half the transition growing away from the direction you want it to go. Okay, let me copy this and then we'll modify what the text is. Okay, so okay, and this is ease in back. Okay. This is ease out back, not the steakhouse. Okay, so this is away from the goal and then beyond it. Okay. Whew. And we've got two more with all three variants. Two more functions with all three variants. Yeesh. I'm sorry. Again, this is not great content. I just... how would you describe elastic? Eases... I think that that's a way to say it. You know, again, these are like qualitative descriptions, not mathematical ones. So, I mean, it's oscillating on a sine wave with This is out. Eases by. I want to say eases by. English is a language. Okay. And this is eases by oscillating with decreasing. And so maybe this is more increasing around the start. And then increasing amplitude around the start and decreasing around the end. Okay. In, out, elastic. All right. What can we say about bounce? Oh, that was another interesting thing about bounce in our Bezier implementation is that in order for that pre-computation of the curves to work. Oh no, it's okay, Kaigen Games. Like that's a reasonable thing to assume that the PAL function might not be defined at that point. I think that's a pretty reasonable thing to assume. I was just thinking from the you know, pen and paper mathematics, you would say 0 to the 0 would be 1 because everything to the 0th power is 1. But yeah, with the exception of I to the 0th power is I think. But okay, so I could be wrong on that too. Don't quote me. So bounce was funky in our implementation because you could not. So like, see how it's a bunch of successive points which are 0. The pre-computation meant that you could not. You had to have some floating point error. Error is not the right word, but like you'd have very, very minuscule difference between the first point of the bounce and the second point of the bounce, or on each bounce, because it was, how do I describe that? If you didn't, like, it got into a pathological state where like there was a singularity at the point at which the two Bezier curves attach. I don't recall exactly why, but so there was a little bit of like, we'd start with 0, and then the next one would be 0 and a bunch of zeros and like a 1 or something, and the next one would be 0 and a bunch of zeros and a 2, and like it wasn't perceptible by a human, but mathematically we couldn't have those points be equal. It was weird. Little trivia from my time working on animation software. Okay, so this is going to be okay, so this is he's in bounce, and we'll modify our documentation text there for the other variants of this, and that'll be the last bit. Okay, so when we say eases in by bouncing, eases out by bouncing, returning to the end several times. When we say like, You know what? I'm not going to make this too complicated. It just eases out by bouncing. Bouncing around the start. Okay. Eases out by bouncing around the end. Okay. It's one of those things where like how do you describe this sort of thing? It's very basic, and yet it's so basic it's almost esoteric. Okay. So all right, so we're gonna do the test now, and let's look at what they do in the Lustre UI tests, because I think that that's gonna kind of tell me what I need to know about how to structure this. Okay, so they're doing this plot. And this plot function okay, it just makes a snapshot. And this make plot the steps is okay, so they wanted to do 35 steps. That's pretty reasonable, right? I think that's pretty reasonable. Okay, so we're going to import Easings here. And I don't want to use a set. And I'm not sure what this float.round is for. Maybe it's here, let's look at that function in the standard library. Float round. Rounds to the nearest whole number is an int. Why would you do that? Let's see, into float steps. Oh, so they're trying to get a number between 0 and the number of steps, and the number of steps is 35. Okay, so there's some loss of precision here. What we might be able to, because this birdie snapshot is going to be like text, right? No, that's not what I want. We could restrict the precision. That might be a way to do this in a way that is more consistent. Say like we only care about, I don't know, 6 or 8 decimal places. That might be a reasonable way to do it. Because what we want is consistency here, and like floats are notorious for having rounding errors. There's not a, and I say not rounding errors. They're errors based on scale. The thing is though, like between 0 and 1, you have the most precision, right? When you get above 1, like every time you get a power of 2 above 1, you get less precision. So I mean, we could do something like loosely equals, but yeah, I think the way to do this would be, say, 2 precision, and just pick an arbitrary number there and see if our snapshots pass. Seems like a reasonable thing to do. Okay. So let's make the I don't see any reason why we can't use 35 steps again, right? And let's say we want to do something like what they did here. We're just going to take function and then what is this show plot? Oh, they've actually made a string plot. Let's, is there, where are the snapshots gone? Here's birdie snapshots. Let's look at this. Oh, so they're like that's interesting. That's not what I would do. Okay. That's kind of fun, though. Okay, so here we go. So we're going to make a... we'll call it snapshot easing, and we'll take a function which is it's an easing, and I don't care what we return. We'll return nil. So we're gonna say we'll do something like this. I think we'll use fold right or fold R. I don't know which one it is. Yeah. I wonder if 35 steps are enough. We're not going to do that show plot. I think we're just going to do string inspect. Okay, so let's do F, and we're going to say, we'll call it compute steps. And then we'll do string inspect. And we'll say birdie. And we need a title. Snap title. Okay. So let's make compute steps here. We're gonna have to, okay, so we imported birdie, good. So we're gonna take the function, which is an Easings function, and this is going to return a list of tuples of floats, 2 tuples of floats. And so let's do, we'll do it similarly. Fold right, though, because I want it to come out in sequence order. Fold right. Okay, we'll do list range 0 and steps. And we'll give it an empty list. Okay, so inside this folder, this folding function, right, so we'll do, let's call this step. And because I want t to be int to float, step divided by int to float, steps. Okay, and then we're going to say Yeah, y is fine. F of t. And then what we're going to return is we're going to put a tuple in here, and it's going to be t. And we might want to limit the precision on t as well. I think that's pretty reasonable. And we'll say ... points. Okay. We could start with this, but let's do float to precision y, and let's make a constant up here, and let's just say 8 places. I think that that's sufficient. Precision. Okay. So now we can just make some linear test. Just make some of these functions, and I'll just throw all of them in there, and then we can run through the snapshots and accept them and move on. You know, this is the thing that I struggle with this as far as the tests go, and you can see some of the tests I wrote for this, like, they're kind of crazy. They're not great. So there's our first example. And we'll do, and here, let me, oops, pop that over to the right so I can see it. I'm gonna hide the terminal for now. And this will be quadratic in. Quadratic out, and here we go with the tedium again. Sorry, folks. But if I get this in a good spot, we'll we can play with our game. Okay, so now I have these. We can just dupe for cubic. Wish there an easy way to, maybe if I can get them on one line, get them lined up as best I can, and then just do vertical editing. The problem is when I go and I hit save, it's going to I don't know how to do that in Z. Some editors have this thing where you can select the same word in a block and change it. But I'm going to do it vertically. And I have to redo my vertical there, so that things are lined up. And then we'll do this with the rest of them, and it should be a lot easier. It should be a lot quicker to edit it. So this is cubic, and this is cubic. Okay. That went kind of weird. Okay, so now we'll do quartic. we'll do quintic. Quintic. Oops, I shouldn't have undone that. Vertical edit. Quintic. Okay, and then we have sign. Oh, did I mess it? What happened here? Oh, it did not copy right, and I didn't notice. All right, I'm just gonna have to fix this. And then it like, yeah, it messed this up so bad. Here. My cat is having a real one out there. I don't know if y'all can hear that. I hope you can't. He's feeling all his feelings. Okay, so let me just axe that because I want to make sure that these are correct. Cubic in. Okay, this needs to be labeled cubic out. Quartic in, quartic out, quartic in, out. Quintic in, quintic out, quintic in, out. Okay. In, out, in, out. In, out, in, out, in, out, in, out. All right, let's get this realigned. And then I'll copy paste it for sign. I think it's just the combination of the vertical editing with the duplicate doesn't work right. All right. We're on sign, and then there's exponential. Okay. And then we have, oops, circular. I'm sure there's an easier way to do this, but I messed that up. I'm an old man, and so I sometimes do things the hard way. So what are you all working on? Obviously you're here for my stream. I appreciate that. But I'm hoping you wanted to come and see how you can use Gleam to write games. There was recently, okay, back, elastic, and bounce. Let me just back and elastic and bounce, and then I don't have to flip. There was recently the game jam, right? So the winner was announced, and I have not played their game yet, but there was an interesting submission also from the creator of Gleam, Louis, and one of his friends, and they made something like Duolingo, but for Gaelic. I don't remember if it was Scottish Gaelic or Irish Gaelic, or one of the others. I think this is Welsh considered Gaelic. I don't know. But that was hard because I don't know any Gaelic. I tried playing their game and it was bad. I mean, my performance was bad. Their game was great. But they did it pretty simply. It was just a web page using Lustre, I think, which is pretty cool. It just goes to show, like, you know, we get so obsessed sometimes with doing like the fanciest graphics and things, but games should really be about the gameplay, right? Okay, let me make sure that this is looking okay, and then we'll. I want to make sure we got all of the easings. Okay, and then let's see what we need to do with Birdie. Run your tests and then review with Gleam, run Birdie. Okay. Excuse me. Okay, we're gonna remove these. And we're gonna save, and it's gonna reformat everything. That's fine, because hopefully we only have to do that once. So now we can run Gleam test. Okay. I think I need to constrain the precision on those t values as well, because if there's any drift, yeah, let's go ahead and add that. The other thing we could do is we could do this up here. Yeah, let's do that up there. And then there's not a question of, well, did you constrain the precision before or after? And I'm gonna, just for safety's sake, I'm gonna put brackets around that. Okay. Okay, so there's new snapshots. They failed. Okay, so that's looking good. I mean, I think 8 places is sufficient. There's not really much more we need to test here. I think. There are some things about, like, we want to make sure that it doesn't panic, right? Other than that, I'm not incredibly concerned about what the values are, except for things like, you know, back is going to go beyond. So the scaled t values are going to go beyond the beginning and the end. Other than that, I think we're good. I mean, the linear, the t value should equal the scale value, and this is maybe that's okay. So let's do what they say: Gleam run -m Birdie. Okay, so there we're actually getting, because we scaled it before, so we're not getting an error between. Okay. Quartic out. Okay. Bounce. Bounce in. Yep. I think this is an okay way to do it. I mean, the probably the way that Lustre UI does it is better for um, visualizing, knowing that they plot it. But I'm less concerned about that. So I'm just going to accept them all. Some things I want to look for here are, 0, 0, and 1, 1 at the beginnings and ends. If it's an in-out, there should be 0.5 in the middle. Except if we're doing 35, we're going to skip the middle one probably. So, all right. Okay, let's look at our Gleam Tommel. Okay, so we're gonna do let's uncomment these. For animation in pure Gleam. Licenses can be MIT. For now, GitHub, user, Sean Cribbs, repo, I just called it Easings. It's fine. We can adjust that later. Can we do Gleam doc? Is that what it is? It's Gleam docs build. Okay. Let's look at that. Oh, why are you so small? Okay, I need to adjust the README. Okay. Okay, and we're going to the right thing there. I'm gonna check all of these real quick. Okay. Okay, bounce in, out. Because of the way that those are, alphabetized, you get the in out before the out, but that's okay. Okay, so that the bounce out has the wrong it has the wrong docs. So this is good. This is good to check. Ease out bounce. Okay. If we're really quite a bit lazier, we may be pulling this in just to check. I would lean on an LLM here, like I would at work. Just be like, hey, what did I miss? We may do that. I don't really have I don't have an enterprise access to any of them here. I may just use the GitHub Copilot and see if it comments. Okay, ease out expo, that's correct. Okay, there is no, okay, ease in quad, ease in out quad, ease out quad, okay, quart. Okay, quintic. In and out, ease out, section. Okay, so let's fix up the README and then we will go. So I'm going to say this is, we'll use the same description we used in the Gleam tunnel. Okay, and this is where you see import Easings. And then we'll make an example here, import Gleam IO, and say something like, or maybe we can just use echo. We don't need Gleam IO. Let's say like Easings dot bounce in and give it 0.5. Do something like this. Pipe and then echo. Yeah, so there's a stupid example. Compute the easing for bounce in halfway through the transition. Okay, that's a good enough example. Like honestly, these functions are so simple. I don't want to do too much, but I want to make this. I want to make this particular README not look like crap. So. Okay, so let's make a commit. Yep, let's go ahead and add everything. First version. Okay. I know that's really dumb, but okay, I don't think that there's really anything else we need to throw in here. Let's look at what we can do. I don't. Let's see if hex. I have a hex password. Okay, copy. Okay. So this is the first time I published a hex package. That's pretty cool. Okay. So let's see. I'm going to go ahead and git tag this right here, and we'll push the tag. I'll just use Gleam publish. What other commands are there? I want to set this up actually as automatic. Let's look at the GitHub workflows. So there's the test workflow. And I have published things to hex on my GitHub account, so there's probably, won't be in this one. But like, for example, hard hat in Elixir, I do publish that automatically on release. Okay, so I have a hex PM key on my account. I want to make sure it's not in this repo. I think it's an account level secrets. No, that's a repository secret. It's not an account secret. Well, we can do that later. So why don't I just do Gleam publish and see what happens. Okay. It did push those, but I want to make sure that it pushes the right. I didn't see it rebuild them, is why. Okay. So now we can go to hex PM and we just published this package. Nice. And we can go to the documentation and it's there. There we go. Good work. Okay, so let's go back to our game. Finally, wow. What I can do is I'll do this off stream. I think we've done enough with the easings for today. I will rework my Tiramisu patch to use that library, and then we will refactor that maybe at a later date. But here we are. I want to get our thing going so we can see where we were. Again, I haven't looked at this in a week, so okay. Oops, that's too big. Okay, so here's our game board. We don't have any controls hooked up. We've got some D20s sitting there spinning around. Actually, I think they're D12s, but I'm not sure. But that's just mostly so we can see our lighting. You know, again, our controls don't do anything. So, and I would like to get different shapes for each of these. So in our code here, we had, you know, we have this. We're doing a lot here in the board. I want to look at the scene IDs because, okay, so I'm going to rename this to ring group because I want to look at the rotation bit because we will be, when somebody has one selected, right, and we'll need to figure out how to show selection. That'll be part of the game state. And we hit rotate. We want to rotate all the pieces, right? So we want to rotate it around the center as a group. So that's going to modify the transformation of all of those things. And if we look at, let's look at the groups that we have here. So these are just the rings that are sitting here behind the scene. Okay, and they all have this transform of 0, 0, 100. So yeah, and that's here. We don't need to look at that right now. What I want to look at is, right, so these are the pieces. Except I actually don't want a flat map here. I want to rework this because what we should be doing here is creating a group for the pieces for each of the rings. Yeah. Yep. Okay, so we've got the board. Okay, so I'm going to say this is list map, first of all. And that's going to break everything. So we'll say let pieces equal that. And collapse that so I can see what I'm doing. Right, okay, so now we're going to make an empty scene. The ID is going to be board ring group. I'm going to import that board ring group. Yeah. I knew I was going to have to do this, which is why I created that. And then our transform here, we'll use identity for now. But what we're going to have to do is make one that's a rotation. Based on the that transition, right? So I actually think I want to move, like, these pieces don't need to know their vertical layering. That could just be 0, right? Okay. Okay, what's wrong here? Ring name. Okay, so it's not broken. I didn't break it. Let me put a to-do in here. Look up the transition for the ring to see if it needs rotating. because over here in our core, we have this this transition rotate ring. And that'll, you know, we have 8 positions around, 4 on the vertical and horizontal, and then 4 on the diagonals. So what we'll want to do is when one should be rotating, we want that to happen continuously, which is why we have this transition type here. But I don't want this tween to be over a transform. It's going to be over a float, right? We'll just do from 0 to 1 and multiply by whatever angle. So maybe we can do that. Let's see here. So let's do case of get from the board.transitions. And the entity we want, and let's say this is going to be let transform. Let's go ahead and do this. This is not entity, but this is a good way to like see it go between the layers here. Okay, so how are we defining the entity? Entity is a ring entity. Ring name, right? Okay. And if we get rotate ring, right? So we're going to say, okay, rotate ring, and there's direction, and there's tween, right? Tween. Then we'll do something. If we get anything else, we're just going to do transform identity. And then I can extract that out, and it's just a variable. So we're going to do transform identity, and then we're going to rotate X. We're going to say direction is going to be a case. Let's see. We'll call it rotation direction. If it's left, we want to rotate in a positive direction. If it's right, we want to rotate in a negative direction. So left is counterclockwise, and right is clockwise, and negative angles go clockwise. So we're going to rotate Z, actually not Y. So we'll do rotation direction times maths dot pi divided by 4, right? Because 0 be here. We want to rotate 1/8 of a circle. So 2 pi being the circle, 2 pi over 8, so pi over 4. Okay, and then we're going to multiply all of that. So that's the base rotation. We're going to multiply that by whatever is in the tween. So animation dot get tween value. Tween. Okay, so I need to import Gleam dict. Okay, so we're still fine there. Um, now what I need to do is we have our board. Um, it's filled with fake stuff. Where did we define that? Like new board, right? Okay, so what I want to do here is I'm going to change this to from list. I want to insert a transition at the start. And this is dumb, but we need to test, right? So we're going to test the rotation here. And we're going to go from... We're going to rotate... Let's rotate the outer ring. Again, this is dumb, but we're going to rotate the outer ring, and we need that ring transition thing. Rotate ring. Let's rotate right. Okay, and then we need... Okay, so the tween float, and this is probably, we're going to make a rotate tween, and this is going to be animation tween float, and we'll just make this a thing that we can call at any time. Okay, so we'll say rotate tween. So this takes start and duration. Okay, so start is going to be 0, end is going to be 1, because remember, using this as a scale. We could put the rotation bit in here, but I don't know that matters. I like thinking about the geometry separate from the transition animation. Okay, so this takes start and duration. I don't know that we put any constants. So like piece exit, it takes 100 milliseconds. Let's just use 100 milliseconds for now. And then the easing is going to be easing dot or animation linear. This one we don't care. Why is that? All right, well, it doesn't like the label. That's fine. We can do it without labels. Okay, so let's have it take a whole second so we can actually see it happening. Okay, so that's wrong, first of all. But the other thing that's interesting there is, let's have it take 3 seconds. So it rotated all of them, and then it popped down. The thing is, Yeah, I guess if we're going right, yeah, that would be correct. It should pop down into that row. Let's change it to left. Yeah, we've got something wrong there. So let's look at. Okay, so we're taking each of these rows, right, with the label. And actually putting a really long time on that is nice because we can see it happening. What is weird to me I want to like kind of unpack this a little bit because I think it's getting confusing. And then we'll get rid of this. Flatten it a little bit. I don't usually like doing this, but like there's enough here that, and let's convert to function call instead of pipeline. It should not be reusing the transform. We should be getting a different one for each ring, right? So maybe let's this is dumb, but I'm going to put it in there, and we're going to look at the console. So it's only the outer one that should be transitioning, but for some reason all of them are. All right, let's look up above. Okay, so we've got so if we're in game or paused, right? You get the rings, you got the pieces. And we're pulling this out of the board. I wonder if I just have some lingering state. That's bad. Here, let's clean that. Anything in... Okay, we can do it here. Just have it rebuild things. We can get rid of all these. And we're going to do... Let's rename that P transform, or even better, group transform. Because I think that there's something, it's probably not going to make a difference. It's still doing the same thing. But I'm not, like, if I comment this out, no transition happens. I'm only transitioning the outer ring. What if I change this to inner? They're all still rotating. They're all still rotating that direction too. And so my angles are incorrect. They're reversed, and maybe it's because Z is out this way, and so that's fine. That's easy to fix. Let's fix that first. Let's make this negative and make this positive. And then that's rotating right, so it should go right. Okay. The thing is, if it's right-handed, Z goes into the screen. So yeah. The problem with Euler directions, it gets really confusing quick. Okay. Let's do, because I want to see. Yeah, like those should not be moving. Why are they even moving? Am I not? The question in my mind is, are these distinct enough? Here, we can get rid of that. Oops. We can get rid of that echo because it's just spamming the console. I think what I've established here is that the logic is correct, that when this transition ends and we can evaluate the drops, then the thing falls to the correct place. So the logic is correct there, regardless of which but our display is not, for whatever reason. And that's really frustrating. These are supposed to be independent of one another. Right, the Borg group has an identity transform, so it should not be rotating any of those things. This is so confusing. I know this is going to be bonkers, but yeah, you can see those things rotating around. Can I just pause the interpreter? Is that possible? Just pause, please. I want to look at some of this. What I'm concerned about is if these IDs are not distinct enough. And I dug into this before when I was running into some issues. Like I dug into what Tiramisu does. And I'm trying to remember if I can. Okay, so let's look at internal object cache. It's mostly the ID thing. So, right, so like, I wonder if we can call this directly. Yeah, let's here, I'll close that for now. Wow, that is broken. He is really not happy. I think it's partly the live reload. let's see. The main thing, shoot, here, bring it back into that window. Okay. What I want to do here is, I think the pieces are fine. I'm concerned about this. I'm going to import it's going to complain that I'm not using that, and I want to do ID toString this. Okay, those are coming out as the same ID each time. That's part of the problem. That's why the rotation is not working right. Why? Do I have a bug in Tiramisu here? I swear I looked at this before and it was fine. So like if I go to serialize ID here, okay, so this should honestly be in 3, not in 3JS because it's not part of that FFI, but where was it? Serialize ID. What I'm not, so these are all, pause please. These are all the same ID, always. We're echoing it right here, and that's the problem. They should come out as separate IDs though. Well, okay. Here's what we're going to do, because I want to close out the stream for the day. So I'm going to note that what we did here was okay, we're going to do this. Ring name to group ID. And then we'll make another function as well. So this is going to be name is a rename. And what I want to do is, this needs to be an int. The thing is, this is board ID, right? Okay, so this is variant 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's fine. Then it's saying the first element in there I'm not wholly convinced that this is going to be correct anyway. It's saying use constructor 0 again, which doesn't make sense to me, because this would conflict with the rings themselves. I might need to just flatten this. flatten this. I'm going to use ints. Yeah. Okay. Rename board ring. Rename. That's fine. The piece is fine. That doesn't need to be. Okay, so I'm gonna rename this to ring pieces because we're gonna have ring patterns as well. And then this is gonna be, yeah, we're gonna say ring pieces, and we're gonna move this. And this is just going to be a simple mapping here. I'm concerned about this not handling this case. This might be something I bring up with the authors, but we're going to move this up into here, get rid of board ID, and get rid of that variant. And this is going to be an int. And then there's going to be a whole bunch of stuff that breaks because I'm going to have to fix those. But let's do it. It won't take that long. Do I have that even imported? I do. Game scene. Okay, so we'll do that. Let, and then we'll echo ID toString of ring ID, and then we'll put that in here. That'll fix one of the things, one of the renames. And then up here in this, that's actually down here, we're flattening this. This is board ring. We don't need that ring group anymore. Board is not a thing. This is a little bit disturbing that that's a problem, but it's not stable under nesting, and that's okay. So let's clear, refresh. That's what we wanted to see. And you can see here that that's actually coming out with different IDs. So I'm a bit frustrated. That this is a thing. We can get rid of those echoes. Okay, now you can see it like immediately drops. Boy, it is like, it gets completely unresponsive. And I think I need to adjust, I need to do something about that. Like I can't even close the tab, right? Wow. There's some bits in there where I probably need to be yielding somehow. Inline that variable. We don't need it separate. Okay. Well, we resolved that issue. I think this is a good place to stop. And and we'll pick this up next time. We rather than having these canned things, we'll start to hook up the controls that we've defined to the actual transitions. And and then we'll move on. So we'll do some other fun stuff. Anyway, thanks for joining me on the stream. Hope you stuck around through all this. We did a ton of just like kind of uninteresting coding, and then we finally got to something that was fun. So we will see you next week.